Yeah. So this evening, we're going to introduce some geometrical concepts, right? We'll talk a little about lines and angles and triangles and quadrilaterals and polygons in general and some of their properties, right? So let's start with, in geometry, you'd hear some terms. And I did send some notes to you, right? Did you see those notes?
Yes, sir.
Yeah. So they explain, well, okay, you can start with a point, right? And they're telling you that, well, a point in geometry is basically a location in space or on a surface, right? And later on, you're going to learn that, you know what, points can be located in what we call the XY coordinate plane, XY coordinate plane. So, okay, a point might be here. You might either see it as a little X, and where that intersection is happening, well, that's a point, or sometimes you see a little dot with a circle around it, right? And those are indicating points in the XY plane, you call this. It's a two-dimensional plane. It has an X coordinate and a Y coordinate. So sometimes you see this little division, like, okay, down here is 1, down here is 2, down here is 3. Right? 0 here, and then something I get 1 here, 2 here, you know. Then you also have -1, -2, -1, and it goes on, right? Good. So this can go in that direction, this can go in that direction, yeah. And the coordinates maybe of this point here is 1, 1, right? This force number here is the X coordinate, meaning, well, okay, what number does it correspond to on the X axis? This is the X axis. And what number does it correspond to on the Y axis? This is the Y axis. So the X coordinate is 1 and the Y coordinate is also 1. So this one here, the point is 3, 1, right? The X coordinate is 3, and this here is the Y coordinate, right? So in geometry, you're going to hear a lot about points. Points in a plane, points in the XY coordinate plane. The XY coordinate, sometimes you have hyphen here, coordinate plane, right? Good. Then you're also going to be introduced to lines and line segments, right? So a line segment is, okay, maybe from one point here to another one there. I'm not drawing very straight yet. I should be drawing a straight line. So if you have a little portion like a line there connecting 2 points, right? This line connects from here to here. You call it a line segment. This is a line segment. Line segment. Over. It's basically a part of a line that connects 2 points. Hence the name segment is a piece of the whole thing. Right? So if it connects A is a point. So we just talk about points. B is a point, and there's a connection here with the line. Because this line doesn't extend infinitely in both directions. You say it's a line segment. It's just a piece of a whole big long line, right? But then if you have now this line extending in both directions infinitely, right? So you have a line that's going, I'm putting these arrows to mean that this line continues on and on and on. Well, now we have a line. This is a line. That's a line segment, right? From here to here is a line segment, a piece of a line, right? But this here is a line, right? Think you're getting it? It's all in the notes too, right? Once you can't remember this, it's in the notes, right? And then you can have something called a ray. So let's say you have a starting point here. You see how the word point coming back steady, right? And then, you know, it's extending to in some direction, right? Then you can refer to this. Let's say this is A here, right? And all right, let's say some other point and it is called B here, right? You can now refer to this as a ray, right? And you see the ray AB, right? The reason why they put the B here, they don't want to say the ray A, right? Because A will only kind of point to the initial point. But you put a second point somewhere on the ray because you want to see which direction it's going, right? So putting the point B there will say, okay, if you extend the line from this point through B and going on like that, well, then you have the ray AB, right? Following me so far? Another term you will hear a lot in geometry is angle, right? And you can have an angle formed when two lines intersect one another, right? So you have a line like that, you have a line like that. So they intersect here, they meet here. And in here, right, you have an angle, right? As a matter of fact, you have two intersecting lines like that. This is an angle between there. That's an angle. This is an angle as well, angle. This is an angle, right? This is an angle, right? So it's not restricted to just like this, they meet here, you have an angle in here. The two intersect like that. Yeah, all those are angles. And later on, we'll learn how we measure this angle. We measure it in degrees, right? And you'll learn more maths. You'll hear about measuring angles in radians, right? Degrees, you're like, okay, if you say 30 degrees, and there's a little circle on top here, right? Radians, you say, are 1 radian is a little c. Right? You can also have an angle formed when you have, okay, you have a line like this, right? A horizontal line. You have a horizontal line, right? And if you were to take this line and rotate it up, right? And the line ends up there. Oh my, that's supposed to be a line, right? Sorry about that. So the line's initial position is here. And this line is rotated, and this is the final position. Final position, then an angle is formed here. So then you hear theta, those are letters, Greek letters that can be used. You see, you hear about alpha, you hear about beta, those are all Greek letters that they would use to represent angles. So that's another way that an angle can form, where you have a line, it's at a particular position, then it's rotated anti-clockwise. And when you rotate anti-clockwise, you get positive angles. But if you study maths more and more and more, you will hear of negative angles too, right? And that's when you rotate the line in the clockwise direction, right? But you will be more concerned with positive angles. Stick with that. Stick with that, right? And speaking of rotating clockwise and anti-clockwise and so on, right? You will hear of terms like rotation, and revolution, right? So sometimes these words are used interchangeably, but you basically mean like, okay, you have a clock, and what happens to the hands? The hands go round and round and round and round, right? It revolves around a certain point in the center, right? And that's where that word comes from. The hands of a clock, some people say it revolves around the point in the center here. Here, some people use the word rotate and revolve, right? They have some slight differences, but you hear them used interchangeably a lot. All right, so we talked about clockwise, anti-clockwise rotation. We talked about measuring the angle and so on. Yeah. And I guess you might be familiar with, okay, certain angles, their names and so. You ever hear about, okay, right angles? Like when two lines are like that and it makes a right angle, that's a symbol for it. A right angle is equal to 90 degrees, right? Then you might hear of the angle on a straight line, right? So let's say this is the point of, rotation. So you have this line and you rotate it to make it into a straight line. This angle here, right, is 180 degrees, right? You'll hear some terms like acute angles. Those are angles between 0 and 90 degrees. You're going to hear about obtuse angle. It's all in the notes there. That's angles between 90 and 180. We hear about reflex angle. That's angles between between 180 and 360. We hear all those terms. You with me so far?
Yes, sir.
Yes, sir.
Yeah. It's all in the notes. All you have to do, take the time to read it. They're all there. And the reason why you want to know these things, because when people are going to talk geometry, use these terms. And if you don't know what they mean, you will have no understanding of what you're talking about. And you can't solve problems that involve geometry, right? So you have to know these things. Right? You'll hear of things like what? Complementary angles. complementary angles, right? And those are angles that add up to 90 degrees, right? So if A and B are complementary, then A plus B equal 90 degrees, right? 90 degrees. You're going to hear about something called supplementary angles. Supplementary angles. Right? That is when two angles add up to 180, no, not 90 degrees, 100 degrees. Right? You with me?
Yes, sir.
You're going to hear about adjacent angles, adjacent angles, right? So if you have like a line here, and here's an angle there, and here's an angle here, and these, oh, they don't look the same, but they're the same. Let's say these are the same, right? So yeah, all right, they don't have to be the same. If there's an angle here, so this is like a common, well, I think it takes, we use the word arm or initial position, you know? And an angle is formed here, and another angle is there. If you call this one alpha and this one beta, you say these two angles are adjacent, right? They have a common vortex here, and they have a common initial position. So you say A, alpha, and beta are adjacent, right? And the word adjacent simply means just alongside one another, right? That's what it means. You with me? So I know you're here. Yeah. And then sometimes you get, you might have like, okay, lines like this, right? Two lines intersect, and you have an angle here. Let's say this one is A, this one is B, this one is C, this one is D, right? So when two lines intersect like that, you will find that A will be equal to C and B is equal to D, right? And we call them, these are vertically opposite angles, right? I don't know why they use the word vertically. God, this looks vertical, B and D, but A and C doesn't look vertical, right? When they intersect, so the angle that is opposite one another, they're equal. They're equal. Then you might hear of corresponding angle, right? And that's like, okay, if you have, all right, you have a line like that, you have a line like that, and let's say a line cuts across like that. This angle corresponds to this angle, right? So if here is okay, let's say here it's C and this is G, then C equal to G, right? Sorry, CG equal to G. Right, similarly, if this is B, it's probably B, and this angle here, whatever it's called F, then B is equals to F, you know. This angle is going to be equal to this angle, and then this angle is going to be equal to this angle, because they seem, well, look at them. They look like they correspond to the same position, like, you know. The intersecting line with the parallel lines. Oh, these two lines gotta be parallel, right? They're parallel lines. That's another term you will hear. Parallel lines are two lines that are a certain distance apart, and they're always that distance apart. No matter how far you go, they never meet. Right? So those are corresponding angles. Then you hear of alternate angles. Alternate, let me go back here. Alternate angles. And there's a popular one, they say this here, get a Z. This angle, right? If these two lines are parallel, if this line is parallel to this one, then these two angles are the same, right? If the Z is turned around the other way too, no problem. They also call alternate angles. So if this is alpha and this is beta, alpha equal beta. Then you will hear of another term, interior angles. Interior angles, right? And these are like, when you have like what we call a triangle, the angles in here, these here, inside here, those are interior angles. These are all interior angles, right? And you're going to hear about interior angles of a triangle adds up to 180, right? There's a theorem like that. Exterior angles might refer to, okay, this angle outside here, right? The angle outside here, that's an exterior angle. If you were to project this line up through it, this is an exterior angle. That's outside of the triangle, and that's what you call it that, right? Are we okay there? And then, well, you all heard of the protractor, no doubt. Protractor. That's what you use to measure angles, right? Protractor used to measure angles, right? So I see. I think that's what your protractor looks like in your what do you call it? The geometry. Yes, this is a protractor, right? So when you're measuring angles, so Let me see if I can move it aside. So let's say you have a line somewhere here. You want a line that makes, let's say, 30 degrees with this line here. Right? So you take this protractor. Oh, there. All right, let me go first. So I have a line. This is my center point here, right? So I want an angle that makes 30 degrees here, right? So what I could do, I can take my protractor, right? Put the center there. So yeah. And I will see, you see here? 0 degrees, 10 degrees, 20 degrees, 30 degrees. And that's my, right here, you might put a little dot, you know? And you know, this is our center here. Right? So when we move out the protractor line, oh gosh, the point come out of it. We go there and let's come out here. Yeah, that's somewhere here, you know? So let me take this out. Oh god, the line going with it. That's what I'm saying, right? You draw down this line here. You draw this line straight down here. Right? And you remove the protractor. The program isn't allowing me to do it, right? But you get an idea. And there are lots of techniques, like when you want to draw parallel lines, perpendicular lines, there's some drawing techniques for all of that, right? We won't get into that. Those are not part of your course. But parallel lines are two lines that are, they're equally distant apart. So if down here is, let's say 5 cm, down here is also 5 cm. You know, there's the same distance apart no matter where you go. They never meet. Perpendicular lines are lines that meet at right angles, 90 degrees. There are construction techniques and so that you can learn how to do it with a compass and a ruler and so, which really wonder, it might be difficult to do on the computer. But I'll probably send I'll send see if I get a video of the construction being done, maybe a YouTube video or so, right? Yeah. There are lots of construction techniques, and they're all in the textbook. The chapter that I sent you, they're all there, right? You can learn how to construct 30 degrees, 60 degrees, 90 degrees, 45 degrees, and so how to bisect angles, and that sort of thing. Good. So what we want to turn our attention to is some familiar shapes in geometry. And very famous of those are the triangle, right? Triangle. And then they have, well, a lot of types of triangles, right? We'll hear a lot of types of triangles, right? They have, we'll call a scalene triangle, scaling. This is where, you know, all the sides are different. No two sides are equal, right? Scalene triangle. Then you hear of isosceles triangle. That's where you have two sides equal. So let's say scalene, they're all different, you know. None of the sides are equal. But in an isosceles triangle, maybe what you have, this side and this side might be equal. And this is how you indicate that, right? You put a line through it here, and a line through it means that these two are equal. Right? Then you have your called equilateral triangle. That's where all three sides are equal. Right? I think earlier we talked about the right angle triangle, right? The right angle triangle is the one where the triangle has 190-degree inside, right? 90 degrees. That's a right angle triangle. Right angle triangle. Right? Sometimes some people say that's right angle. They don't have the abbreviation here, nor do they have the D at the end here. They just say right angle triangle. Right? Right angle triangle. This longest side here, they call it hypotenuse. Hypotenuse. The hypotenuse. Right, and triangles have some properties, and so I think I mentioned one earlier that the angles in a triangle add up to 180, right? So if you have a triangle, and here is alpha, this is beta, this is gamma, alpha plus beta plus gamma, interior angles add up to 180 degrees. Right, that's a property of triangles, right? Very popular property. Later on, I don't know how we can do it, but we can use a compass, and so on the computer, you would have seen how they can prove then that these three angles actually add up to 180. You know? And then there are construction techniques to draw these triangles. Right? There's some construction techniques which they call for some use of the protractor and compasses and so on. Right? It might be difficult to do on a computer, but it's easier to do on paper, right? I'll see if I can figure out a way to do it right on this computer here. Right? You'll hear of another theorem in connection with triangle. You'll hear of congruent triangles. Right? And when two triangles are congruent, right? It means that let's say you have a triangle. Another one here. Oh gosh, this one it has to be the same size, exact same size. So this side will be equal to that side, this side equal to this side, this one equal to that. Angles must be the same. Angles must be the same, right? If two triangles are identical in every way, we refer to them as congruent triangles, right? We talked about isosceles, the equilateral triangle. They have special properties, the equilateral triangle. Go back to that. The equilateral triangle. Equilateral triangle, right? So you have a equilateral triangle. We talked about it, right? This side equal to that side equal to that side. This angle will be equal to that angle will be equal to that angle. They're all the same. Isosceles one. Isosceles. Isosceles. When you have, okay, two equal sides. This side equal this side. Then this angle will be equal to that angle. But this one might not be, it is not the same as this and this. That might not, it is not. If the three angles are equal, well, then you have you have an equilateral triangle. So you're getting a little introduction there to some of these types of triangles, right? Scalene, equilateral, isosceles, right angle, right? And then you can have like, okay, let's say you have a triangle, right? And then you have another one here. So this little one is like a smaller version of the bigger one, right? Then what you refer to, you say that, okay, let's say here is O X Y, and maybe this is OAB. Then OAB, triangle OAB, is similar to OXY, the triangle OXY. And basically what's happening here, right, is that the triangle OXY is like a bigger version of OAB, or the other way around. Triangle OAB is a smaller version of OXY. And that would mean that, okay, like this angle will be the same as that angle, right? This angle will be the same as this one, you know? Yeah. And then the ratio of the sides, like OX over OA, will be the same ratio as OY over OB, and that sort of thing, right? The ratios of the sides will be the same, because one is just a bigger version of the other. You with me so far?
Yes, sir.
Okay. So these are a lot of properties we're covering here, right? Of triangles. A lot of terms you're learning and so on, right? And if you're not clear on it, just go back in the notes. I have all of them there in the notes. You just have to read them and learn them, you know? So when you talk geometry and something like that, a similar triangle, you know what I mean? Congruent triangles, you know what I mean? Right? You hear a scalene triangle and isosceles triangle. You know what I mean all the time. But so now when we talk so much about triangling, there's a famous theorem that governs right angle triangle, right? Called the Pythagoras. Pythagoras theorem, right? Pythagoras theorem. And basically, this theorem, very important and very popular, you hear of it all over. If you were to have a right angle triangle, this side is, let's say, A, this side is B, and this third side is C, right? Then there's a relationship connecting these three sides. They say that, okay, C square is equals to A square plus B square. Sometimes it's written like this. C is equal to the square root of A square plus B square. If you were to rearrange this now, you can get A square is equals to C square minus B square. Or you can get it as A equal to the square root of C squared minus B square. And further, B square is equals to C square minus A square. And if I were to like, you can have it as B equal the square root of C square minus A square. Right? Well, all those are versions of the Pythagoras theorem, right? Sometimes you'll see this version, this one here, or this one here. What they're telling you is that the square of the hypotenuse is equals to the square, the sum, sorry, of the square of the other two sides of the triangle. World famous theorem in mathematics. Extremely useful as well, right? It's extremely useful. So if we're to do an example or two of it, so let's say you have a triangle. And let's say this side is 3 and this side is 4. And you want to find this side. Right? According to the theorem, C is equal to 4 square plus 3 square, which is equal to square root of 25, which is 5. However, not every time you will have such a nice number for the third side, right? You can have situations where the number here for the third side is not nice at all, right? I'll give you an example now. So let's go, let's take one. As a matter of fact, this one, there's a famous story, right? That when they came up with the Pythagoras theorem, right? A man came up with the idea that if you have a right angle triangle and down here is 1, down here is 1, and then down here is 1, then according to Pythagoras theorem, this side will be the square root of 2, right? Because 1 square plus 1 square, the square root of that is really square root of 2, right? And but guess what? When that guy came up with the idea, they did not know of these numbers before. They did not know that, well, square root of 2 is a number, right? And there was a lot of commotion. There's a famous story, and let me tell you this. I don't know if it's true. So there was a group of people in somewhere, in Europe there, and they call themselves the Pythagoreans, right? Pythagoreans. We don't say Pythagoreans, right? I think they pronounce the word Pythagoreans, right? So they're a group, there's a group and they call themselves that. And well, Pythagoras was more than just a mathematician, he was a philosopher and so, right? So they call themselves Pythagoreans or Pythagoreans, right? As a matter of fact, I'm to deviate a little. There is some talk that Pythagoras' theorem was not really discovered by Pythagoras, right? It's a mystery as to how they came up with the theorem, but eventually it took on the name Pythagoras theorem. You know, sometimes you want to name your theorem after somebody or a group of people say, man, you know what, let me name it after this famous mathematician, Pythagoras, right? Not that he actually came up with it, but maths history is so, you know, it's not really well taken out, you know. Yeah, so this guy, when he told, he said, man, if the theorem is right, if I have a triangle, a right angle triangle, where the two sides, the two shorter sides, are 1 each, like you see in the diagram here, then the hypotenuse has to be square root of 2. But then square root of 2 cannot be evaluated exactly, right? So they said, man, it's really troublesome, you know, coming up with this new type of numbers, right? So the story says that what they do, they say, man, let me go for a picnic, you know? Let me go on this island for a picnic. And when they came back from the picnic, the guy who came up with this idea about square root of 2 as a number, he didn't come back. So whatever they did with him, God knows. They drowned him, they killed him. We don't know. But the point is, you know, sometimes when people come up with new ideas, people don't like it. People don't like it. They feel like you want to disrupt everybody, right? And later on, they came up with these numbers like square root of 2, square root of 5, square root of 7, square root of 11. And these numbers became, they call them irrational numbers. Irrational numbers, right? And this particular category of irrational numbers, they used to call it, they came to call them surds. Surds. And if you study maths to that extent, you will learn how to manipulate them and add them and subtract them and multiply them and all that. Right? Yeah, so there's that story there. Yeah. Let's take another one. And maybe we'll take this as the last one. Because I think I did a lot of talking here. I need to talk to you about what our plans are from now on after this. So let's say you have a triangle now. Okay. It's a right angle triangle, right? Right angle. Let's say this is 13. I shouldn't pick 13. All right, let me go ahead. Okay. Let's go with 10, right? Let's go with 18. We want to know what is 8. Can you calculate 8? We know the hypotenuse. We know the second side, 8. Can you say what is 8? Hmm? Anybody listening to me?
Is it 8, sir?
8. 8, you say? 8? How do you get 8? This side is 8. This side is 10.
Sorry, yeah.
How will you get A? What formula will you use?
Sir, can you use a square equals c square subtract b square?
Yeah, right. Yes, you can do that. So you can use a square equal to c square minus b square. So in this case, a square will be 10 square minus 8 square.
So it's gonna be 100 subtract 64 equal 36.
So A then will be the square root of 36, which is, right? However, not every time you have these nice numbers, you get decimals and so sometimes, right? Let's take another one. So maybe you have, let's use some horrible numbers now. So let's say this is 5. Or this is 6. Find this side. Tell me the side C. Maybe round it to the nearest whole number. Nearest whole number. How will you get? Are you using a formula? C equal the square root of 6 square plus 5 square. And we'll get what? The square root of, what's that? 36 and 25 is it? Huh?
6 to 1.
61? Is that right? Or 51? 36 and 25? Yeah, 61. And when you find the square root of this, well, what is it?
7.8.
How much?
7.88.
7.88. Good. So that rounded to the nearest whole number will be? Huh? 7.88 to the nearest whole number.
8, sir.
8, yeah.
Sir.
Yeah. Good. So I think we've covered quite a bit for one afternoon. Right? I want you to read up some more of that notes, and next week we'll continue to talk a little about quadrilaterals and polygons as a whole and some of their properties, right? However, let me stop sharing and let's talk a little about how we're going to do this class from here onwards. Yeah. So what I want with our class is I want you to be involved some more, right? So let me see, today is what day? Today is Wednesday. So we have the whole week until Monday. So when we have our class, right? I'm going to give you all, every one of you in the class, I'm going to give you a little activity to do, a little assignment to do. So the assignment you see in the course outline isn't going to be one big chunk of assignment you take home and somebody do it for you. No. I'm going to give you a set of questions, maybe each one of you 2 questions. I'm just saying, right? 2, something can be less, it can be more. You're going to work it out. Maybe you can, if you want, type it up if you want, or put it on a PowerPoint. If you want to write in an exercise book or an art page, take a picture of it, that's up to you. And during the class, you're going to share your answer with us, right? And I'm going to give you a mark for it. So you don't have to wait for no assignment. Every week you will get an assignment. It will keep you working, it will keep you developing, give you something to do, because some of you are just listening passively, and God knows if you're making notes, if you're watching the video I'm putting up, you know? So I'm going to give you a little bit of work to do, right? And so we're going to spend about an hour where you are going to do some work, and then I'm going to now teach you something new every time. So the following week, so what I teach you today, I'll ask you some questions. Next week, you'll do some exercises for me, and you'll get marks for it, right? So keep that in mind. So look out on the WhatsApp group, as well as, yeah, I can put it on the WhatsApp group. I'll assign all of you a question or 2 for our next class, right? Sometimes all of you might not be able to present in a single class. But we'll try to. Y'all are not plenty. Y'all are barely, 16 people, right? So you should be able to present. And you're going to be given very simple things. It should only take you about less than 5 minutes. Less than 5 minutes, right? So in an hour, all of you supposed to present what you were given to do, and then we do something new, right? Y'all understand that?
Yes, sir.
Yes, good.
Yes, sir.
So
Yes, sir.
yeah, beginning, maybe look out in the WhatsApp group either. Maybe tomorrow, Friday, the latest, you'll get a couple of questions to do. Prepare them for Monday, right? And here what's gonna happen. Sometimes all of you can't present on Monday. So I'll probably have about, a couple of you present, and then another couple present the next week, at the next session on Wednesday, right? So you are doing some work, I am doing some work, and we're learning together, right? As we go along. So look out for that exercise come tomorrow or Friday the latest, right? So read up the notes I sent you, look at the videos that I'm uploading. It's really a video of the class. And I think we did quite a bit for this afternoon. Lots of terms and so on. A nice way to end it off is that Pythagoras theorem thing, right? So I don't have to send you notes on that. I already sent you an entire chapter on geometry. That's enough notes already, right? So we can now bring our class to an end. Stop this recording.